Spearman's rank correlation coefficient is used when two variables are expressed in ranks. That is, the values which are ranging from 1 to the highest value where there are number of observations. Let's suppose there are 10 observations are there, then the highest rank would be 10. Depending upon the number of observations, the ranks deviates. That means the rank will be ranging from one value to the another value. And the formula to find out Spearman's rank correlation is 1 minus 6 summation d square by n into n square minus 1, where n is number of observations given to us. That means the number of students or the number of marks, whatever it might be, the total number of observations which are given, number of pairs of observations are given is n value. And to find out d square, first we need to find out only d, where d equal to the differences of ranks between two variables. Now let us take an example of this problem. Calculate Spearman's rank correlation coefficient between advertisement cost and sales. Advertisement expenditure is given in thousands and sales is given in rupees lakhs. That means when a person is investing, that means when a company is investing 39,000 of rupees for their advertisement purpose, then they are getting the sales of 47 lakhs. And next year, let us next or next case, whenever it might be, uh, they have invested 65,000 for their advertisement, so they have got 53 lakhs in return of sales. So that is how different values were given to us. Basing on this data, they are asking us to find out rank correlation. See the concept here. Actually, to find out Spearman's rank correlation coefficient, we should get the values in ranks, but here we have values. We have values. Not by seeing these values, we can say that these are not ranks, because always the value should start with either whether it is with jumbled, the number should start from 1. But here it is the cases of different. But see, for let us suppose if this word is not mentioned over here in this problem, calculate correlation coefficient between advertisement cost and sales. Immediately by seeing this situation, we can solve this by using Karl Pearson's coefficient of correlation. But since they have mentioned as Spearman's, that means I have to convert these values to ranks unless until I cannot find out the value of Spearman's rank correlation coefficient. Let us see how we bring these values to the ranks and how we make up the answer of the Spearman's rank correlation coefficients. I'll use Excel file to solve this problem. See the same problem which I've copied onto the Excel format. Now, there are some values. Let's take an example. These are the marks of the student. These are the different marks obtained by different students. So the first student got 39 marks, and second, that means in the first subject, and in second subject, he has got 47 marks. Okay. Or otherwise, let us take the same example of advertisement and sales itself. For your understanding, I just told you an example. So now I have to find out ranks of X separately and ranks of Y also separately. So now always we give highest marks as our highest rank. So according to these values, now out of these values, the highest value is 98. So 98 will be given as first rank, and the second highest value, that is 90, it is given as second rank. After 90s, let us move on to the 80s. There is only 82, so it is given as third rank. After 82, we have in 70s only two values are there. So 78, it comes to the rank 4, and 75 is fifth rank. After 70s, let us move on to the 60s. So we have two values over here. So 6, sixth rank and seventh rank. After these two ranks, then next the values which are not there in 50, we don't have any 50s, even 40s also. Then moving on to the 30s. So 39, we have 8th rank, next 36th, 9th rank, and the last least variable 25 is given as 10th rank. While assigning ranks, we can verify whether we are doing the problem in the right manner or not. And because once you are done with this column, that means ranks column, the highest rank, that means the number of observations, total number of observations are how many? 10. So that 10 should be equal to our highest rank, or otherwise we are misleading. That means we are doing some mistake in the problem. That is how we can cross check ourselves. So second case, that means in the second column, again, let us assign our ranks. Now, in the second column, the highest value is 99 again. So we will give the first rank itself. After 90s, we have 80s, that is 86 is second rank. Then next, 84 is third rank. We don't have any values in 70s, but we have in 60s. So 68 is fourth rank. 62 fifth rank. 60 is sixth rank. After 60 is 58 seventh, 53 eighth, 51 ninth, and 47 the least value is given as the highest rank. So that is how we found it. That means we have transformed a normal values onto the ranks so that we can find out our Spearman's coefficient of correlation. So now D is nothing but, see, what is the notation I have written here? Since we are given, let us suppose the values of X and Y are given. So I have found out Rx is nothing but ranks of X and ranks of Y. Now D is nothing but ranks of X minus ranks of Y. So now eight minus 10 is minus 2. Likewise, we found out the other values also. Okay. Now 2 square is 4. 2 again 2 square is 4. 0, 0, 4. 1 square is 1. 4 square is 16. 0, 0, and 1. So by adding all these values, that means by adding, sorry, by squaring all the values and then by adding those values, I got summation d square is equal to 30. By simply substituting these values onto our formula, we get 1 minus 6 into summation d square. That is 6 into 30 divided by n into n square minus 1. What is our n value? 10. So 10 into 10 square minus 1. This is the formula. So next, so that is equal to 1 minus 6 3s are 18. So 180 divided by 10 into 10 square minus 1. So 10 square is 100. 100 minus 9 is 99. 99 into 10 becomes 990. Okay. So then 1 minus 180 by 990. Let us see the answer. 180 divided by 990. So the answer is 0.1818. 0.1818. So then that is equal to, we get 0.8181. So the correlation between advertisement expenditure and sales is 0.8181. That means R value is greater than 0 and it is almost 81%. So that means advertisement expenditure and sales are positively correlated. Or otherwise, we can write the statement that the sales increases with the increase of advertisement expenditure, or the sales decreases with the decrease of advertisement expenditure. To simply write the statement, we can use the statement like advertisement expenditure and sales are positively correlated. This is how we interpret our answer by converting values to the ranks in Spearman's rank correlation coefficient.